Okay. Let's see if this is working. Sorry guys if you're on, I'm trying to figure out this YouTube thing. It is not cooperating this evening. So hang on just a second. Okay, great. All right, so this is some help with the first homework block. These are the pages that are on the homework block. If you don't have them yet, they are in Google Classroom, they are in Canvas. So I'm just going to do some of the problems from these so you guys can just kind of get an idea of a few. I'm just going to pick some at random. So if you don't have these, you can write these down when you rewind this video, or just go to Google Classroom and they're all in there. Okay. So if you have any specific ones that you want to see, you can put on there that you prefer it. Like if you have a certain page number, I'm going to start with page 464 and do a couple there. And we did number 10 in class, so let's see here. We have 10, 13, 23, 27, and 34. Okay. All right, we'll do number 13. 13 is one that a lot of people had trouble with. So we'll start off with number 13. This is page 464, and I'll try to find something I can write with here. Hang on a minute. These things never go right when I start them, do they? All right, so we're on page 464, okay? And I'm going to look at number 13 first. All right, number 13 is the one that says, the ratio of the measures of the three sides of a triangle is 9 to 7 to 5. Okay, so we have a triangle, and the ratios of the sides of this triangle that we're looking at is 9 to 7 to 5. Now it says its perimeter is 191 inches. 191.1 inches. Okay, so the question is, it says, now that we know this information, can we find the measure of each side? Well, there's a certain way to do this, and you have several questions on the worksheet as well that cover this. So let me try to explain to you why we're doing what we're doing first, and then I'll go over the solution. Okay, so first of all, what we're looking at here is we've got a triangle. It's a 9 to 7 to 5 ratio. Some random triangle with a 9 to 7 to 5 ratio that has a perimeter of 191.1 inches. Well, what's the smallest triangle that has a 9 to 7 to 5 ratio? Well, the smallest triangle to have a 9 to 7 to 5 ratio is the 9-7-5 triangle, right? Now think about this. 9 to 7 to 5. That's technically 9 times 1, 5 times 1, 7 times 1, right? That's the smallest triangle that we can draw that's in a 9 to 7 to 5 ratio, okay? What's another triangle we can draw in a 9 to 7 to 5 ratio? Well, I can draw one that's a little bit bigger, and I'm not drawing these to scale, okay? So what if I had 18, 10, and 14? So here, what was my ratio? 9 to 7 to 5, right? Well, here, my ratio is 18 to 14 to 10. Now, remember, when you write ratios and you're comparing these values, you want to put it in the simplest form and you want to reduce. So if I reduce this ratio, what does it reduce to? 9 to 7 to 5. What have we done here? Everything here is multiplied by 2, right? So basically, these two triangles both are 9 to 7 to 5 triangles, right? Okay. Well, let's do another one. Let's draw another triangle that's 9 to 7 to 5. Okay. So let's say we've got 27 and 21. Oops. Let's see here. Yeah, 27, 21, and 15. So what are the ratios of these sides? These sides form a 27 to 21 to 15 ratio. But again, let's reduce this. Now, this is not what you have to do for number 13. I'm going to show you the solution in just a second, but this is to show you why we do what we do for number 13. I just wanted to show you a little back story on, or a little back calculation on it. So if I reduce this ratio, what can all of these be divided by? 3, right? Just like simplifying a fraction. So this reduces to what? You guessed it, a 9 to 7 to 5 ratio. This is the same as taking this times 3, this times 3, this times 3. So the 9 to 7 to 5 ratio works for any triangle that can have its sides set up in such a manner that when you reduce the ratio, you get 9 to 7 to 5. So we're looking for that one particular triangle that gives us that 9 to 7 to 5 ratio that has this perimeter. Well, what's the perimeter of this one here? 9 plus 7 plus 5. That's 16 plus 5. The perimeter of this guy is 21, so that's not it. The perimeter of this guy would be 18 plus 14 plus 10, right? Which would be 42. That's not it. The perimeter of this guy would be 27 plus 21 plus 15, so that's 48. So that's 63. So that's not it, right? We're looking for something that's going to add up to what? What perimeter? 191.1. So the question is, all we have to do, or not the question is, but what we have to do is we have to find out what to multiply 9, 7, and 5 by to get a, so that when we add those together, like in these situations, we get a perimeter of 191.1. Well, we multiplied all of these by the same number, right? These were all multiplied by 1. These were all multiplied by 2, by 3. We want to find that factor. We don't know it, so we're just going to call it x. So the way we're going to set this up is 9 times some number x. We don't know what it is. It's not 1, it's not 2, and it's not 3 because we've already looked at what happens to those perimeters, right? So 9 times some number plus 7 times that same number, because didn't we multiply all 3 sides by the same factor to get the similar triangles as we got bigger? Plus 5 times some number is going to equal 191.1. Okay, and I just realized I don't have my calculator with me and I don't want to think tonight, so we might have to do a calculator thing. So I'm going to combine. I've got 9x plus 7x plus 5x, okay? So I've got 16x plus 5x. That gives me 21x equals 191.1, okay? After you do that, you're going to divide both sides by 21. And I don't have a calculator, so I'm going to go to my computer and do the calculator. So I'm going to do 191.1 divided by 21. And the answer is 9.1. So x is equal to 9.1. So this is one of those, however, that we're not quite done yet. It's not asking you just to find x. What's it asking you to find? The actual measures of the sides. If you look at number 13, it says to find the measure of each side. So what do you think I'm going to do with that x? I'm going to take it and plug it in. We did a lot of plugging in the first semester. So we're going to plug it in. So I'm going to do 9 times 9.1, and that's going to give me one side. I'm going to do 7 times 9.1. That's going to give me the second side. And I'm going to do 5 times 9.1, and that's going to give me the third side. And again, I'm going to use my calculator because I don't want to think tonight. 9 times 9.1 is 81.9. Okay, and remember, we are looking at our units here. Don't forget your units. The units are inches. I know this question's taking a little bit longer than some of you probably wanted it to, but I wanted to explain to you why we solved it the way we did, okay? 7 times 9.1 is 63.7 inches. That's the second side. And 5 times 9.1 will give you the length of the third side, which is 45.5 inches. So these are your three answers. How could you check your answers? Well, what should they add up to? They should add up to what? 191.1, right? So when I add these guys together, I should get 191.1. So let's check it out. 81.9 plus 63.7 plus 45.5. And let's see what that gets us. So we have 45.5 plus 63.7 plus 81.9. And we get 191.1. So that's good. So we got the answer, okay? So those are the three correct answers for number 13. 81.9 inches. And remember, units, 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 okay? Make sure you put your units on there, all right? Okay, so that's number 13. We had quite a few questions on 13. So I'm going to jump over to the next page, and I'm going to do number 27. 27 is one that a lot of people are having questions on because back in middle school you were taught bat and ball. The intentions were well, you were well intentioned, but bat and ball doesn't always work. So let's look at number 27. Number 27 says, this is still on page this is still on page 464. So now we're looking at number 27. Number 27 is 3x minus 1 divided by 4 equals 2x plus 4 divided by 5, okay? Now, when we talk about this, this is what we call a proportion. Remember, these are ratios. A ratio is a comparison of two values using division. And our last quiz, we asked 3 ways that you can write a ratio. So this is one of the ways you can write a ratio, fractional form. And that's what we use it more consistently in that form in geometry. You'll see it more in that form. You will see it with the colon as well when we're not having to solve for a value, like we did earlier on the previous question. Okay, so what do I do here? Well, this is a proportion, a comparison of two equal ratios. So what I want to do first, whenever I have a problem like this, and I know I have to cross multiply, and I have a binomial, or I have a term right here, that is one quantity, I'm going to do this. Because when you cross multiply, people tend to always forget that you're cross multiplying this value times this entire thing. It's this times this entire thing. So I'm going to cross multiply. This is number 27 on page 464, okay? I'm going to cross multiply with a better pen because this one sucks. Sorry, did I say that out loud? So I'm going to cross multiply here and cross multiply here. Anytime you have a proportion, remember this is a proportion, all of the stuff we're doing with similarity has to do with being proportional, meaning equal ratios. I'm going to set it up this way. So on this side, I have 5 times the entire quantity, 3x minus 1. On the other side, I have 4 times the entire quantity, 2x plus 4. A lot of you made mistakes because you don't put the parentheses around the value and you only multiply it times 1. This value has to be multiplied by the entire thing. Again, if you just came in and you hadn't seen all the video, the reason I put those blue parentheses around there is to indicate that that is an entire quantity. So I know I'm multiplying that times that. You don't have to, but it's just something that helps you when you do the multiplication. All right, now I'm going to use the distributive property. I'm going to distribute. 5 times 3x is 15x. 5 times negative 1 is negative 5. And then on the other side, 4 times 2x is 8x. And 4 times 4 is 16. Okay? So all I've done, I cross-multiplied. If you want to make a pretty butterfly, because I'm just the amazing artist I am, there's your butterfly. I cross-multiplied and then I distributed. So now after I've done that, I simplify it just like any other algebraic equation. So let's get all the x's on one side. So I'm going to subtract 8x from both sides. And that's going to leave me with 7x minus 5 on one side and 16 on the other. After that, I want to isolate the constants. I've gotten all the variables on one side. Let's get the constants on the other. It's a minus 5, so I'm going to add it. So 7x is going to equal 21. Okay? Yes, you're going to get a nice even answer, unlike the evil decimals I usually give you. So now the last step is going to be divide both sides by 7, and x is going to equal 3. Now, you can always go back and check your answer. If you want to check your answer, if you want to check it, take the 3, plug it in, okay, and then see, does the equation work? Or meaning, does the equation balance? So let's plug the 3 in. So if x is 3, that means on top I have 3 times, what's x? 3 minus 1 over 4. You don't have to do this step. It's just if you want to check your answer. And then I can plug it in up here. 2 times 3 plus 4 over 5. Those should come out to some equal values if that's the correct answer. What's 3 times 3? 9. 9 minus 1 is what? 9 minus 1 is 8. So I have 8 over 4. That is going to reduce to 2. Okay, let's check and see if it's equal over here. We technically should not write the equal sign yet because we don't know. We're testing to see if that works. So you may not want to write it too soon. It kind of helps just keep your equations separated though. And it's not really an equation until we show they're equal. Tricky there. So 2 times 3 is 6. 6 plus 4 is 10, so I have 10 over 5. What is 10 over 5 reduced to? 2. Therefore, they are equal. You've just checked your answer. Okay. So that is number 27, I believe. That's number 27 on page 464. Okay. So those are 2 big questions from page 464. So now I'm going to move on to page 473. Because we don't have that many people watching, so I'm going to go ahead and go on to page 473. All right, on page 473, we had 8, 9, 12, 15, 16, 18, 21, and 32. Okay, so let me check one of these out. Let me do number 9. I'll do number 9, okay? Number 9, all right. Number 9 says, let's see here. This is on page 473. So now we're on to a different page. We're on page 473. So we're going to look at number 9. On page 473, number 9, we have JHFM, quadrilateral, is similar to PQST. Okay, I'm going to try to recreate the picture and using my awesome artistic skills. So this is what you see in the textbook. I can't get the textbook in the frame just because of the way things are set up this evening. I apologize. So I'm just going to recreate whatever I can. And then we have one that kind of looks like this. Another little guy over here. And that's Q, and that's P, and that's T, and that's S. Okay. So basically what we have on this one is the question is asking. It says list all pairs of congruent angles and write a proportion that relates the corresponding sides for each pair of similar polygons. This is similar to one of the ones that you had on the quiz. So let's look at what we have, okay? All right. Match up similarity. And remember, this means similar. Similar meaning same shape, okay? Same shape. Does not necessarily mean same size. It means same shape. But what that means is I can match up my angles. Since I've already had this stated that they're similar, I know that J and P are congruent. So I'm going to put one arc on J and one arc on P. I know those two guys are congruent because of the way it's stated. Remember, order matters when you name your polygons. I also know that H has to be the same as Q. So H goes with Q. Okay, so I put 2 arcs for those. The next one I'm going to match up is F goes with S. So F has 3 marks, or 3 arcs, I apologize, and S has 3 arcs. Okay, so those 2 guys match up. And then the last one is M matches up with T. So M has 4 arcs and T has 4 arcs. Okay, so what I've done is I've just matched up the congruent angles. So let's list them. All right, let's list them. Your congruent angle pairs, we'll start with the green one. Looking here, for your congruent angles, angle J is congruent to angle P. Okay, angle J is congruent to angle P. Your second angle pair, angle H, is congruent to angle Q. All right, that's your second angle pair. Your third angle pair is F congruent to S. Angle F is congruent to angle S. And your fourth angle pair is that M is congruent to T. Angle M is congruent to angle T. So those are all the angles, and those are easily matched up. And again, because of the name, we knew which angles were together. The next part of the question says to write the proportion that relates the corresponding sides for each pair of polygons. So now we got to match sides up. So we got to match sides up. So what we're going to do now, sorry, my little one came in. Okay, thank you, honey. Mommy's teaching. No, don't do that. Stop. Go. I'll come talk to you in a minute, okay? All right, so what we're going to do is we're going to do the same thing we did to match the angles. Please, not now. So JH on this one matches up with PQ on this one. Because how do I know that? Well, first of all, JH and PQ are in that sequence here, right? So JH over PQ is one of these. Okay, so that's the first one. So JH goes with QP because it wants you to write the proportions out. So the next one, and again, you can also match these up. JH connects what? 1 arc and 2 arcs. PQ connects 1 arc and 2 arcs. So you can use your angles as a reference as well. So let's do the next one. We know that HF, if you look at HF right there, HF, and we're not doing scale factors, so we're not doing pre-image over image. Otherwise, we'd put this one on top. Okay, so this is just doing proportions. So HF over QS, okay. And I promise on the next example I'll do that because I know that helps you guys out. FM goes over ST, okay. And then the last set that goes together is JM over PT. So those are that's the proportionality statement that it wants. It wants you to match up the sides that go together. If I were to actually plug in values for these, I would get the same ratio for all of them. Now, once again, this is not scale factor. If we were doing scale factor, remember, is image over pre-image. We would do this one over this one because when we don't indicate an image or a pre-image, we go left to right. But since this is not scale factor, we're just doing the proportion. Now, could you have written it the other way and written PQ over JH and QS over HF and ST over FM and PT over JM? Yes, you could have. Okay, that would have worked. All right, so that's number 9. So let's see if we can get, let me look at one of the other examples. We've got 8, 9, 12, 15, and 16. Okay, I'm going to do number 15. So I'm going to move this up a little bit. Okay, so let's do number 15. I'm going to do number 15. Number 15, you have a square. And I'll go ahead and draw the picture again so you can see it. I apologize for not being able to have the book. Sorry, my daughter came in and was being kind of a pain in the bootay. So you have A, D, G, K. This is 6. This is 8. And then you've got a smaller one, just like this. Okay. And that's W, M, Z, L. And that's 4. And that's 6. Okay. So what the question says here, determine whether each pair of figures is similar. So our first question is, are these guys similar? Yes or no? If they are similar, write the similarity statement. So if yes, we need the similarity statement. And then we need the scale factor. So these are the 3 things we're examining in this question. So the first thing is, are they similar? Well, let's look at them. First of all the angles are the same, right? They're both rectangles. But remember, just because the angles are the same does not mean the figures are the same shape. For example, if I have a 4x6 rectangle like this one, and I draw a 4x4 square, don't those have the same angles? They do, right? But 4x6 and 4x4 are not the same shape, yet they have the same angles. So just because they have the same angles does not mean they are the same shape. You have to get a little bit deeper than that. That only works in triangles, okay? So let's see if they are in fact similar. Well, they passed the angle test. Even though knowing the angles are the same is not enough, you have to know that. You really need to know that. So let's look at the sides. I've got 2 sets of sides here. And I want to know if those sides happen to be proportional. Now, I'm going to go ahead and I'm going to go with the ones that match up the way the picture's drawn first and see if that works. So the first thing I'm going to do is I'm going to compare, and I'm going to go ahead, we are looking for a scale factor. So here is your image, and here is your pre-image. Okay, and you remember your scale factor is image divided by pre-image. So are these 2 guys similar? Let's check it out. Image, 4 over pre-image, which is 6. What does that reduce to? 4 over 6. That reduces to 2/3. So 6 over 8 would have to give us the same ratio. Okay, would have to give us the same ratio. So let's try it. 6 over 8. What does that reduce to? 3 over 4. Not equal, not similar. Therefore, you don't need a similarity statement and you don't have a scale factor. Simple, right? Now, if those had come out to the same ratio, that ratio would have been your scale factor. Okay? And then to write the similarity statement, it would be just like the similarity statement up here. You would say JHFM is similar to PQST, but you would match up the angles here, if you can still see that. You would write, this is a similarity statement. And you can only write that if the 2 figures are similar. Okay? All right, so that is number 15 on page 473. I'm going to do one more from page 473. And let's see, what's the lucky winner? Let's see, we got 18, 21, and 32. Let's see here. Let's do 18. I'll do 18. Why not? So we're going to do number 18 on page 473, which is actually on page 474. So page 474 in your assignment, number 18. All right, number 18 says each pair of polygons is similar. find the value of x. And I had quite a few questions on this in class today. So that's one of the reasons I'm picking this one. So I'm going to redraw these figures. Okay, you've got your first figure, which is A, G, D, C. And this is x plus 5. And this is 4. And this has 2 arcs. And this has 1 congruence arc. All right, and then we're going to draw its neighbor, which is this one. And that one goes this way. And then you have on this one W, T, Q, Y. And that's 5. That's 15. That's got 2 arcs. That's got 1 congruence arc. Okay. So they tell you in the instructions that these are similar. So I already know that they are similar. Check. They're similar. I know they are. Okay? So based on the information that they provide you here, you can't really find any other angles. So we're going to use what we have. Okay? So what you have to do is find the value of x. Now, to find the value of x, we have to set up our proportionality statement. Remember, your proportionality statement is basically your proportion for the sides, comparing the sides. It's what you would use to find the scale factor, basically. All right, so this is our image, and this is our pre-image. Now, we're not finding a scale factor here, but I want you to get in the habit of identifying your image and pre-image because that makes a difference when we find the scale factor. Okay, how do I match these up? Well, you have to look carefully at what you're presented with. The angle A is congruent to angle Q. You do know that. And C is congruent to Y. Based on what you see here and the information you're given, we can only set up one proportionality statement. We don't have all the sides. We don't have all the angles. So all I can do is set up one proportionality statement. So let's match them up. Where is the 15 situated? Oops, I'm sorry. The 15 is situated between Q and Y, right? So let's come over here. Q and Y match up angle-wise to what? A and C. So 15's counterpart is x plus 5. That is your image over pre-image. So let's get something to compare it to with the other sides. The 5 comes off of the 1 arc congruence, and then there's nothing. The 4 comes off of the 1 arc congruence, and then there's nothing. So 5 over 4. Why am I setting these equal to each other? Because in the instructions, it says that they are similar. So what I'm going to do now is I'm going to solve it like a proportion. So I'm going to cross multiply. Remember, put your parentheses around your binomials so that you can remember that you're multiplying by the whole binomial. Put your little butterfly. So what I end up having is 4 times 15 is 60. And then on the other side, I have 5 times the quantity x plus 5. That's why it's good to put parentheses around the pieces of your fractions, okay? Now I'm going to distribute. So 60 equals 5 times x is 5x. 5 times 5 is 25. And then I'm just going to solve it just like algebra. So I'm going to take the constant 25 and subtract it and move it over here. So I get 35 is equal to 5x. Okay. And then for the last step, I'm going to solve for x. I'm going to divide both sides by 5. X equals 7. So 7 is your missing value. Okay, if you want to check and make sure 7 is correct, if you just joined us, we are on number 18 on page 474. If you want to ensure 7 is correct, we're going to take 7 and we're going to plug it back in and see if we get 2 equal ratios. So let's plug in over here. 15 over x plus 5, which is 7 plus 5, because x is 7, equals 5 over 4. Let's see if that works. 15 over 12 equals 5 over 4. And again, this is not equals yet. We don't know that. We're trying to prove that that's equal. So you may want to circle it just in case, so you know that it may not necessarily work. It should if we solved it right. If you reduce 15 over 12, both of these can be divided by 3. You get 5 over 4, which does in fact equal 5 over 4. So you have checked your answer and it is good. You don't have to check it, but that's if you want to make sure. Okay. So those are the ones I'm going to go over on page 474. So I'm going to move now to page 483, do a couple of more. On page 483, you had a host of problems. So let's go ahead and start with one of the baby ones. We'll do number 10. So this is page 483, number 10. Okay. Page 483, number 10. Okay, number 10 says, determine whether the triangles are similar, and if so, write a similarity statement. If not, what would be sufficient to prove they are similar? Okay, so let's take a look at this. I'm going to draw the picture that's in your book. Again, because I love to demonstrate my artistic skills. So I'm drawing what's in the book. You've got B, C, D, F, and A. So the instructions say, first of all, are they similar? So you need to know, are they similar, yes or no? That's the first question. If yes, you need a similarity statement. And remember, the similarity statement is just the blank, blank, blank is congruent to blank, 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 or similar to blank, blank, blank. Okay? If not, if the answer is no, what information do you need? What info is needed? Okay? So that is the map out of what you're doing on this particular question. Okay, so let's look at this picture. I have absolutely nothing in this picture that tells me these are similar. I have no side markings. I have no angle markings. Nothing. So there's a couple of options. First of all, imagine looking at these triangles as separate triangles. I'm going to separate them for you. We have triangle ABC, right? And then what's the big triangle? Good Lord, that's a horrible picture. The big triangle is ADF, right? So those are your two triangles. We're trying to prove they're similar. Well, first of all, okay, whoops, I wrote this wrong. That should be A, that should be B, and that should be C. It's late. They both have this angle, right? We already know they have that angle. Do you remember the ways that we can prove things are similar? We can use AA, we can use SAS, or we can use SSS. So if I want to use AA, I'm halfway there. So the question is, what other piece of information would I need to know that those guys are similar? There's different ways you can go about this, okay? I'm going to make it simple for you. You would need to know that this angle is congruent to this angle. So, first of all, are they similar? No. You don't know. Okay. Second of all, I can't write a similarity statement because they're not similar. So there's none. If the answer is no, what information do I need? Well, I would need to know that angle B was congruent to angle D. Now, what could I use? AA, right? What else could I have said? Instead of saying angle B congruent to angle D, what else could I have said? I could have said, well, I need to know that C is congruent to F. That would have put me in the same spot, AA. All right. There's another way you could have done it. I could have said BC is parallel to DF. Okay. So I'm going to write all the possibilities. Or you could have said angle C. Whoops. I probably should be is congruent to angle F. Once I separate them, it's okay to say C and F, but when they're connected, that should be ACB and AFD. That would give you AA. Or I would have to know that BC is parallel to DF, because then what does that give me? That gives me the corresponding angle congruence, right? Which would mean that these pairs are the same, which also could give you AA. So those are the different possibilities for number 10, okay? It's, no, there's not enough information to say they're similar, so I can't write a similarity statement. What information would I need? Well, you could know B is congruent to D, or you could know C is congruent to F, or you could just flat out say B, C, and DF are parallel, which gives you B and D and C and F. And all of those would give you AA. We can't do SSS or SAS because we don't have any side lengths, okay? Okay, so let me pick another one. Moving right along the chain here. Let's see here. Let's do 18. That's nasty. Ooh, that's a nasty one. So let's look at 18. So now I'm going to do number 18. Okay. We're still on page 483. Number 18 says identify the similar triangles and then find the measures. So bear with me as I try to draw the picture from 18. So I've got this, and this is W, U, this is Z, this is Y, this is marked with an arc, this is marked with an arc, this is marked with a right angle, this is x plus 6 for this piece, this is 3x minus 6 for this piece, and this is 40. Okay, so the first question is identify the similar triangles. Well, if that's a 90-degree angle, what's this? That's also 90, right? Okay. What I'm going to do is the same thing I did in the previous one. I'm going to split these apart. I'm going to take triangle A and triangle B, and I'm going to split them. So let's do the small one first. The small one is this. That's W, whoops, W, U, Z. Got a right angle there, an arc there, 3x minus 6 here, x plus 6 here. Okay, that's this one. Okay, I'm going to split them apart. Now I'm going to draw the second triangle for you. Okay, the second triangle is this one. So I'm going to pull that one out, draw it over here. And we've got W, U, Y, and that's 40. Okay. So the question is, the idea is to identify the similar triangles. Okay. Well, if you remember, what can we use to prove two triangles are congruent? What are the three methods? Not congruent, similar. AA, SAS, or SSS. What do I have here right off the bat? AA. These are similar by AA. And now that's important because that's going to help you match up the triangles. Okay? If these two angles are congruent and these two angles are congruent, what can I assume? These two angles have to be congruent, right? Because all triangles add up to 180. So I'm going to identify the similar triangles first. I'm going to write my similarity statement. This is my similarity statement, okay? I'm going to call the first triangle WUZ. WUZ. That is similar or the same shape as what configuration here? Well, think about it. I went from one arc to the 90-degree angle to the two arcs. So I've got to match up. So I'm going to go from one arc, which is Y, okay, to the 90-degree angle, which is U, to the two arcs, which is W. So there is your similarity statement. Those are your similar triangles. WUZ is the same shape as YUW. Okay? All right. Now that we've got that established, in the book, they want you to find the lengths. They want you to find the distance from W to Z and the distance from U to Z. Okay? So in order to do that, we have to set up some proportions. Okay? All right. Look at the pictures that I drew. Look at the pictures that I drew. We've got similarities here. We don't know exactly what those similarities are. We don't know what the scale factor is, but we want to find out what's missing. In order to find out what's missing, we have to set up a similarity statement. Okay, we have to set up a similarity statement. So the question is, how do we do that? How do we do that? Well, this is kind of a tricky question, because what you end up having to do is you end up having to set up, have to end up setting up a similarity statement with these values. And one value I did miss is this is 32. Okay, so let's write our proportionality statement out first. Okay, let's go off the similarity. What does YU go with? WU. What's the length of YU? 32. And that goes over WU. Do you know WU? Okay. You don't, right? You don't know WU. So we're going to call that Y. We don't know what that one is. All right, so let's look at the next one. UZ, okay, and UW go together. So UW, do you know UW? Okay, we don't know UW, so I'm just going to say UW. And we don't know UZ, we know UZ is x plus 6, okay? So far we've got two. Now we're going to get the third one, then we're going to see where we can go from here. The last one is YW goes with WZ. And I wrote those out. What is YW? YW is 40. So that's 40. WZ is 3x minus 6. Okay, so here's the problem. And I'm going to go ahead and cross these out because we'll put these in there. I don't have a set proportion where I can just solve. I've got 2 or 3 different things missing. Here's where the Pythagorean Theorem comes in. Okay, so you need the Pythagorean Theorem. On the Pythagorean Theorem, you're missing this side right here, right? Okay, now this side would be the same too, right? WU and WU, okay? So that's that Y value, right? Okay. Now look at this one. That's UW again, isn't it? So couldn't I call that Y also, or B, or whatever I want to call it? In fact, I'll call it B because I wrote B on there. So now I've got 2 that look alike, but now I still have a problem because I have to do cross multiplication and I don't know what some of these represent. So I'm going to find B. I'm going to use Pythagorean Theorem. So a squared plus b squared equals c squared. A squared is 32. 32 squared plus b squared equals 40 squared. And if you want to set this up right off the bat on subtraction, most of you know how to do that. Okay, so I'm going to do 32 squared. That's 1024. plus b squared, okay, equals 1600. Now I'm going to subtract 1024 from both sides. So b squared, okay, b squared equals 576. All right. If you take the square root to solve for b, okay, if you take the square root to solve for b, you should get 24, I believe. So b is 24. Now I've got a value for this side, and I've got a value for this side, and I can solve. Okay. So this one's a little more complicated. Now I've got b. I'm going to plug it back in. So 32 over 24. Sorry, this is so sloppy. It's late. I'm tired. Equals 24 over x plus 6. Now I cross multiply and divide. So I'm going to cross multiply. So I get 576 equals 32 times x plus 6. I'm going to distribute. I'm running out of room here. 576 equals 32x plus 198, I believe. Let's see, 192. I'm sorry, this is running out of room. I'm going to subtract 192 from 576, and that gives me 384. So 384 equals 32x, and then I'm going to divide both sides by 32. So x is 12. I apologize, this is so bad on this one. I'm so sorry. X is 12. But you had to use Pythagorean Theorem. I'm sorry this got so sloppy here. Totally my bad. So I apologize on that one. Okay. So I've done a couple from each section tonight, and hopefully that helped you figure it out. And you can look at this as review. Remember, we do have the quiz tomorrow. So again, I apologize for this being so messy and sloppy. My mind's all over the place right now. I've got other things I'm thinking about, and I just kind of went a little crazy there. So anyway, I hope this helped.